Hello. So we are finishing up module 1 today. So just a reminder, distance and displacement. So what is the cyclist displacement if they go 10 blocks east and 20 blocks south? Okay, so we haven't done much drawing here, but you're still putting it into perspective. So draw a picture to help you out. Okay, 10 blocks to the east and 20 blocks south. So the arrow that goes to the right is going to be half the size of the arrow that goes down. Okay. What does displacement mean? That means just the starting and ending is important, not the path. So if this question asks, what is the cycle's distance? Then you could say it was 30 blocks, because that is the path that was gone on. But the displacement only cares about that start point and end point. So what could we use here to connect those dots? I know this is 10 and this is 20. What do I know about the starting and the ending? Pythagorean theorem. 10 squared plus 20 squared is equal to that C side, or the resultant side square. Okay. 22 blocks southeast. Okay. So if it was going east here and south here, then our total direction is southeast. Now, if the cyclist had traveled all the way back to the beginning, then the final and the initial spot would be equal. So the distance final minus the distance and our displacement initial, or the position final minus position initial, would be 0. So anytime for displacement that it goes all the way back around, then it would be 0. What is the total distance if the cyclist had gone all the way back around? 10 plus 20 plus 22. So read carefully if they want distance or displacement. When we're looking at our graphs here, okay, think about what it means. Okay, condition 1 is this top row here. We're starting at 5 and we're going to 0. So our displacement is we're coming back to the origin position for a certain amount of time. Okay. It's a straight line. So our velocity is constant. So our velocity is a horizontal line. And for our second one, notice it's a curve. So anytime we have a curve in the first one, we're going to have a line in the second one. So in this one, our velocity is decreasing. So it is not constant here. It is decreasing. Our displacement, we're going a little bit at the beginning and then farther displacements per second at the end. And now we can figure out what our velocity is by finding whatever the point is that we are going off of it. What do we know though? Because this is a straight line, we know that our acceleration is going to be constant. So what's that, our next graph going to look like? Our next graph is going to look like a horizontal line because acceleration is constant. So this is the progression you're going to see every time. Horizontal line, that guy's constant. So the one before is going to be a line, either decreasing slope or increasing slope because it's changing with time. And then if you can go back further, if you need to go back further, that would be a curved one. That is how you're going to look at that information. And when we look at the area under here, it is the displacement. area under the velocity time graph is displacement, so they might only show you one of those graphs. Okay, numbers 2 and 4. You might want to, before you take the test, to go back through and do all of this worksheet again. I know it seems duplicative, but it will help you just really make sure that you know how to find the formula for each part. And then in the Zooms, live Zooms, we have more time. So I did do more of these problems than what I do on the snapshot. Number 2. Hey, blah, 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 blah. All that up there is just extraneous information. Good information to learn about, but extraneous. Okay, she's going downhill. Okay. She starts at rest. So velocity initial 0. And then her acceleration is 6.84 meters per second squared. Use those units as a guide for 2.39 seconds. Determine the distance that she moved. Okay, so what formulas have distance in them? T plus 1 AT squared and the final squared equals the initial squared plus 2AD. So those are our 2 ones. So if we're lucky, we can get it all done in one time. We can't always, but we'll start here. We want the distance. We have velocity initial. We have acceleration, and we have time. Okay, so we could use this top equation. We do not have velocity final. So we would have 2 things missing on that one. So we would be using that top one. Velocity initial times time is 0 plus 1/2. And then our acceleration is 6.84. And our time is 2.39 squared. Okay, and then you can solve that out for finding the distance. Now, I haven't been using the units, but let's use the units this time. We would have, and I'm just going to write the units. 6.84 is meters per second squared, and time is seconds, and it's squared. So I want you to just take a look at that. I just took the units from the 2 guys that we have. 1/2 is a constant, so it doesn't have units. This is 0, so no units there. 6.84 has units meters per second squared. Time has units seconds, and those are squared. And look at that. When I cancel that out, I'm ending up with meters. So using that for unit analysis is going to come in quite handy later. So if you are able to, yes, write the units along each time and start canceling them out at this point for those later levels. According to Guinness, the tallest man he is how tall? 2.72. So that's my distance. You could also label it as a height and meters. And he dropped a quarter. So from the top of his head, all right, so the quarter is going to go down. He dropped it, he didn't throw it down. So what do we know? Velocity initial equals 0. What's the acceleration going to be due to? Due to gravity. Gravity is what's pulling him down, the quarter down. So, and what do we want to find? Determine the speed. So we want to have V final. Okay, and obviously it's going to be right before that impact. So we're going to keep the same distance, okay, because we're going to get that distance right there before it stops moving. Right, so what formulas do we have that incorporate distance? So I could write down all of them, like the V final equals V initial plus AT. But right now I already know And I'm gotten used to looking at this. Wait, I don't have time at all here. So if I need to find time, that's going to be a secondary equation, not a first equation. So I'm going to go again and just write down the equations that have distance. Distance equals velocity initial times time plus 1/2 AT squared. And the second one is V final squared equals V initial squared plus 2AD. All right, so we want to find the speed at the end. So we want to find velocity final. So this equation here, actually, I'm not even going to decode it right now because it doesn't have a velocity final in it. So do I have enough information from here? I have a velocity initial, I have an acceleration, and I have a distance. So that is awesome. I have my information right there to help me out. Okay, when you are doing this, if you set positive as down, then you would have positive 9.80 and you would have a positive velocity final. If you set down as negative, you'd have a negative 9.80. Okay, so just be aware of that when you are solving these problems with the positives and the negatives, just be consistent. I lost my share, hold on. And there's a couple more hints here for some of the other problems as well. All right, next problem to review. Deshaun's little brother is playing marbles. He shoots the marble at 0.1 meters per second. Okay, so that is what? When he shot the marble. So that's our initial velocity, meters per second velocity, and goes by the target marble at 0.075. So this could be one final velocity, might not be the true one that they're asking for, but it is going to be the second velocity at least, accelerating at negative 0.1 meters per second squared. What is the approximate distance? The starting point of the shooter marble was to the target marble. Okay. Ignore the distance the marble missed. Okay, so let's draw a picture. We shoot off the marble and it misses another marble right there. Okay, and they said we could ignore this little distance. We can assume that distance is 0. But there was no impact, so we don't have to work on any of our other momentum equations. So we started off at 0.1 and we ended at 0.075. Okay, so it actually was slowed down or decelerated a little bit at negative 0.1. I want distance again. So let's see if we can do it just with one equation. So I'll write down my distance equations first. And velocity final squared equals velocity initial squared plus 2AD. All right, so what do we have? We want to find the distance. We have the velocity initial. We don't have the time. We have the acceleration. And what about here? We have velocity final. We have velocity initial. We have acceleration. So we want to just plug all that information into this second equation here for distance. And there you go. Have a great day. And you can hear Bella, my dog, getting some water in the background.